So today we're working on notes 3.3a, writing equations of polynomial functions. So polynomials have different names. It's important to understand those names so you can graph it properly. So degree 0 is a constant, right? That's just 5. First degree is linear. We've seen those a lot. You've seen those a lot in Math 1 and Math 2, so x minus 4. Right? Unit 2, quadratics. We saw quite a few of those. So 4x squared is an example. If it's degree 3, right? These are the 3 new ones we're going to see more of. A cubic. So it's x to the 3rd. If it's to the 4th degree, it's a quartic. So x to the 4th. If it's to the 5th degree, it's a quintic. Right? So x to the 5th. So we're definitely going to see a lot of 3, 4, and 5. We'll see some quadratics, but that we won't see as much as we did in Unit 2. So we want to write the equation and sketch the graph. So it's a quadratic, so that means it's the 2nd degree. 0 is at negative 6. 1, 2, 3, 4, 5. So negative 6 and positive 2. Remember, zeros means it has x-intercepts and a y-intercept of negative 2. So we're going to write our equation. We have y equals. If I have 2 zeros, I'm going to have 2 sets of grouping symbols. If it's 3 zeros, I'd have 3 sets. If it's 4 zeros, I had 4 sets. Because each 0 represents a factor in our equation. Right? So this is kind of like 3.2, but going in reverse. So if the 0 is negative 6, so that's what makes this factor equal to 0. That means the factor would be x plus 6. Because if you plugged in negative 6 for x, you'd get 0. So if the factor for the next one is, or if the 0 is 2, then the factor would be x minus 2. What do you plug in for x to get 0? You plug in 2. Okay, and it should be the 2nd degree. Right now we have x times x, right? That would give us x squared. So that is the 2nd degree. So we're good on that part. So now all I really need is a. Right? I need this to figure out what's the end behavior. Do I start high or do I start low? So I'm going to use the y-intercept. Right? 0, negative 2. So x, y. So negative 2 equals a times 0 plus 6. 0 minus 2. So negative 2 equals a times 6 times negative 2. So negative 2 equals negative 12a. Divide. So a equals positive 2 over 12, which is 1 over 6. So then my final equation is positive 1 over 6. So it's positive, it's even. So thinking back to our notes on 3.1, positive and even. So that means it's going to be high to high. Right? Remember, right? Think back. Our box, right? Positive, negative, odd, or even, odd. However you want to do it. But to be consistent. So even is high to high, low to low. Odd, right, is low to high, and odd and negative is high to low. So that means my graph is going to come through the negative 6, back up, through the 2, and the negative 2. And we'll just rewrite this negative 6 over here. So there's your equation, the one I'm circling right now, and then your sketch to the right. So this is having you do both. Okay, example 2, it's a quintic function, so that means 5th degree. Okay, and then they give us this information. F of negative 2 equals f of negative 1 equals f of 3 equals f of 4 equals f of 6 equals 0. So all of those values, when you plug in negative 2, negative 1, 3, 4, 6, you get 0. So they all have some x value and 0. That's what you get every time. Well, which coordinate has a y-coordinate of 0? Those are your x-intercepts that have that. So they're giving your x-intercepts. So I have 1, 2, 3, 4, 5. So 1, 2, 3, 4, and 5. And then they give you the point 2, negative 2. So you have x-intercepts at negative 2, negative 1, 3, 4, and 6. And the point 2, negative 2. Okay, so for writing our equation, f of x equals, so what factor gives you a 0 of negative 2? Well, what do you plug negative 2 in and so you get 0? That would be x plus 2. This would be x plus 1, right? X minus 3, x minus 4, x minus 6. They're just opposites of each other. So if the 0 is negative 2, the factor would be x plus 2. If the 0 or x-intercept is negative 1, the factor is x plus 1. The 0 is negative or positive 3, the factor would be x minus 3. It's opposite signs. Okay, so now we have x 5 times, so I have x to the 5th. So I'm good. It's a 5th degree. Okay, so that means, that tells me that it's going to pass through every one of those 5 x-intercepts because none of them repeat. So same idea. I just have to figure out a. So here's your x, here's your y. So negative 2 equals a times 2 plus 2, 2 plus 1, 2 minus 3, 2 minus 4, 2 minus 6. So negative 2 equals a times 4 times 3, negative 1, negative 2, negative 4. Right, multiply those all together. We're going to get a negative. Right, so we got 4 times 3, which is 12. 12 times 2. Right, gives us 24. And 24 times 4 gives us 96. Divide. A is a positive 1 over 48. So A is positive 1 over 48. So there's your final equation. So we know it's odd, positive, so that means it's a low to high. So we go up, we come back down, back up, back down, back up. Knowing that I have to hit every one of those 6 points. So when I get to the first blue dot, right, I know I have to get to the other blue dot. So it means I have to go through it. And I know that I'm going to pass through all 5 x-intercepts because each factor only occurs one time. Right? The multiplicity is odd. Right? It's the same idea in the last problem. How did I know I was going to pass through the 2 and the negative 6? Well, because each factor only occurred one time. So the multiplicity was odd, so I know the graph passes through. It doesn't bounce off of it. Okay, last example here. Write an equation and sketch the graph. It's a cubic function. So it's 3rd degree. Right, means it's going to be odd. So the end behavior is going to start and end in opposite directions. So f of 2 equals f of 1 equals 0. So that means your x-intercepts are negative 2, 0, and 1, 0. And passes through x equals 1. Okay, so it passes through that point. That means it's got to bounce at negative 2. So again, writing our equation, we have two x-intercepts, so we have two factors, two grouping symbols. So this would be x plus 2, this would be x minus 1. Why is it x plus 2? Because what do you plug into x plus 2 for x to get 0? Negative 2. What do you plug in the factor x minus 1 to get 0? 1. So again, when they give you the zeros, the x-intercepts, if you're writing the equation, you're going backwards. So if it's x equals negative 2, then the factor would be x plus 2. If the x-intercept, the 0 is 1, then the factor would be x minus 1. Now it says it's a cubic. I have x and x. I have x squared. I need x cubed. It says it passes through x equals 1, so that means this has to be squared. It's got to have even multiplicity, so it's going to bounce at 2. Okay, so we know, right, we have x and x, we know it's odd. Notice, right, it says just write an equation, okay? So there's not enough information to technically figure out what A is. Why were we able to figure out A in the last two problems? Because I gave you an extra point, right? I gave you this point, and I gave you the y-intercept. So the last two problems, notice the sentence was write the equation. Or now this is write an equation. So there's not enough information to get the precise equation. We can get one that's going to be very similar to it. So we're not going to be able to figure out if A is a certain number, right? We could figure out positive or negative, but I don't know for a fact, is it 1/2, 1/3, 10, 20? I don't know. There's not enough information. So it has to bounce and go through. Okay, well, if it was positive, right? So it would be positive and odd, then it would be low to high. So it would go here, it would bounce, and then come back through. Now this is one of the rare occasions, and you won't see anything like this on a homework or test, but you could also technically make this negative, right? If this was a negative, then it'd be negative, odd, it would be high to low. And I'm going to show you that real quick in a different color. It would come down, bounce up, and go through. But we won't worry about that, but technically it could be negative as well. But again, that won't happen on a quiz or test. It's either going to be a positive or negative, and there would be enough information to make that distinguished, or make that distinction, sorry. Please make sure you go back, answer the essential question, and write your summary.